Welcome to Calculus 2 Review Quiz 4. So we will discuss midpoint rule, trapezoidal, and other Simpsons rule. And the other question will be checking convergent and divergent of the integral. So let's start by approximate the integral using n equals to 4, or the number of rectangles being equals to 4 of this integral of root of x with respect to x, and the limits being 1 to 5. Let's start by using the midpoint rule. So what we know n equals to 4. We know there is interval from 1 to 5. So that means that the general AB, A is 1, B is 5. And the next thing that we need to have here is we need to find the grid points. So to get the grid points, let's draw this interval from 1 to 5. And then we need to divide into 4 rectangles. So, but you need to have a uniform space for rectangles. So to know the spacing from one point to the next point, we need to get the grid points. So to get the grid points, we need to find the spacing or the length. So let's find the length. The length denoted as nabla x equals to b minus a divided by n. And my b is 5 minus 4 minus 1 divided by 4. So we have 4/4, which is equals to 1. So that means that from one point to the next point, there's a spacing of 1. So here we have a 1 spacing, so we learned to 2. Another spacing from 2 of 1, we learned to 3. Another spacing of 1, we learned to 4, and then 5. So this is 1, 2, 3, 4, 5. Let me give them the general notation. If I call this one x0, this one x1, x2, x3, that one should be x4. Now, the next thing we need to find for the midpoint is to find the midpoint on each and every interval. So I'm putting a star between them to show the mid. So let's first find the mid between x0 and x1. And to find the mid, I'll denote that mid as x1 with a bar. It's the add the two x0 and x1 divided by 2. So that is 1 plus 2 divided by 2. That's 3/2. To find the one which is between 2 and 3, let's denote it x2 with a bar. We have x1 plus x2 divided by 2. That is 2 plus 3 divided by 2, which is 5/2. And the one which is between 3 and 4, that's denoted by x subscript 3 with a bar. That's x2 plus x3 divided by 2. That will give you 3 plus 4 divided by 2, that is 7/2. And as you can see, the trend, it's 3, 5, 7, so that one should be 9/2. So x4 with a bar should be equals to x3 plus x4 divided by 2, which is 4 plus 5 divided by 2, which is 9/2. So we have all the grid points, x1, x2, x3, and x4. Now, so we have all the midpoints. To find the integral, so we need to find the area under the curve. And to find the area under the curve, we find that, see these rectangles. So if I was to draw the rectangle, like a typical rectangle here, the first one in the interval, let me just use this one rectangle. And I have x0 here and x1 here. Then the height, I'll be using the midpoint here. So this should be my height, one that I'm drawing dotted one here. So, and to find this height, I need to substitute the value at x1 or the x1 value in the function root of x. So this one should be f at x1 bar. So this is just square root of the value x1 bar, which is root 3/2. So meaning that the area of this rectangle should be the distance between x0 and x1, or the length, which is just 1. Let me give it the notion, notation, then multiplied by f at x1 with a bar. And so we can find all of them using the general formulation. At the midpoint, I'm putting 4 to show the number of rectangles. It's just length times width, or base times height, and the base, it's uniform, f at x1 for the first rectangle, plus the second rectangle, the spacing is the same, so uniform length, and then the height, I'm using the height at this between the midpoint, f at x2 with a bar, plus the third one, in third rectangle, I'll be using the spacing, which is uniform, and then f at x3 with a bar, and we found it, plus the last one, f at x4 with that bar. So simplifying, we have that all of this, the interval, it's uniform, which is 1. So I can just have 1 times f at x1, which is square root of 3/2, plus, again, 1, f at x2, and x2 is 5/2, so square root of 5/2, plus, spacing again, it's 1, f at x3 with a bar, that is square root of 7/2, plus, again, 1, uniform length, f at x4 bar, which is square root of 9/4. So it's like we are adding all those numbers, square root of 3/2 plus square root of 5/2 plus square root of 7/2 plus square root of 9/2 using a calculator. This one will give an answer which is 6.7980. Let me leave you the answer up to 4 decimal places. So that's the answer for the midpoint rule. For the trapezoid rule, it's that we need to have, if I was to use the same interval, and you have 1, 2, 3, 4, and 5, because we need 4 rectangles. So 1 rectangle, 2 rectangle, 3 rectangle, 4 of them, 4 rectangles. And then let me have a rough sketch of the trapezium. If I was to draw a trapezium, sorry, trapezium like this. So a trapezium has these 2 parallel sides and this one which is perpendicular one. So the one here, if I call this one f at 1 and this one is f at 2, if I was to draw another trapezium here, sorry, let me clear that one. This is another trapezium of that form. This will be f at 3. Another trapezium, if I was to do another trapezium, f at 4. And finally, another one here. My diagram is not that clean, f at 5. We observe that the first one, the trapezium number 1, the area of the trapezium number 1, let me call it A1, A2, A3, and A4. We find that the first one, trapezium, trapezium rule of 4. The first one is, formula for trapezium is you add the 2 parallel sides, f at 1, add f at 2, we divide by 2. Then you multiply by the perpendicular distance, which is times 1. Let me use this notation. Plus the second one, they are sharing an f2, so it's f2, one of the parallel sides plus f3 divided by 2 multiplied by the interval or the length plus, now I'm in A3, and A3 has F3 as one of the parallel sides plus F4 or F at 4 divided by 2 multiplied by, again, the spacing. Finally, the last trapezium, A4. So the area, it's F at 4 plus F at 5 divided by 2 multiplied by the spacing. Finally, if we were to factor out the spacing, we end up getting F at 1 plus F at 2 divided by 2 plus F at 2 plus F at 3 divided by 2 plus F at 3 plus F at 4 divided by 2. And the last one, F at 4 plus F at 5 divided by 2. Now, keen observation will show that F1 or F at the first grid point is not repeated, so we can write it F1, F at 1 over 2, and the last one at the last point, that grid point at x equals to 5, not repeated, but all the others are repeated. And it's F at 2 over 2 plus F at 2 over 2, that's just F at 2, because it's like a half plus a half. F at 3 over 2 plus F at 3 over 2, just F at 3. Finally, F at 4 divided by 2 plus F at 4 divided by 2 is just F at 4. And this can even be generalized to give you the general formula. So the general formula for trapezoidal rule is you take the interval, the length, sorry, then the first point, let me call it F at naught, divided by 2, or just take F at naught plus F at n, the last one, divided by 2, plus all the others. Let me use the summation sign. N starts from 1 up to when equals to n minus 1, and that you add all of them. So the spacing in our question was 1. The first point, F at naught, is F at 1. So F at 1 plus the last one, F at 5, divided by 2, plus all the others, F at 2, plus F at 3, plus F at 4. So this is now a matter of putting them in the function F at 1. So plug in 1 in the function at square root of 1, which is 1, plus square root of 5, divided by 2, plus F at 2, that's square root of 2, plus F at 3 is square root of 3, plus F at 4 is square root of 4. And then using a calculator, we find that this answer equals to 6.764. The other one is that Simpson's rule. So we are looking for n equals to 8. There's a formula that I gave in class. So, and we say trapezoid rule plus twice midpoint divided by 3 equals the Simpson rule when n equals to 8. So, and we usually use ones when n equals to, n is greater than 2, or equal to n greater than 2, and it has to be even. So n has to be equals to 2k. So in this case, k equals to 4. So we have found s at 8 equals to trapezoidal rule with n being equals to 4 plus 2 then being equal to 4 divided by 3. So when we have both answers, so for the trapezoidal, we have 6.764 plus twice the midpoint, which was 6.7980, 6.7980, all this will divide by 3. And this answer will result to 6.787. But if we don't recall the formula, this one I have written here, if you cannot be able to derive it, then the Simpson rule can be done using the same length in the question divided by 3. If n is equals to 8, then you take the function of values, the starting one and the one at the end, and then the way they are, plus twice all the even ones, plus 4 times the ones in the odd numbers, in the odd positioning of the interval. So if I was to draw an interval of this form, and then I have x naught, and let me say x at 8 because I'm using 8 of them. So this one is x1, x2, x3, x4, uniform spacing x5, x6, x7, and x8. So I'll be able to find Simpson's rule of 8 b equals to the interval. Then I'll have f, the starting point, f at x naught, plus f at xn, the last one, that's the 8th one, plus twice all the f at 2, plus f at 4, plus f at x6. Then after that, I'll find plus 4, f at x1, f at x3, plus f at x5, plus f x7. Once you do that, you get the same answer. Finally, let's do the determine whether the interval is convergent or divergent. If it's convergent, evaluate it. If diverges, enter the diverges. So, and we have the question, integral from 0 to infinity, exponential minus 8x with respect to x. So this will be the same as finding the limit, because you're having improper integral with the infinity as one of the limit. So we need to b to approach infinity. Then from 0 to b, exponential minus 8x with respect to x. So this should be the same as evaluating it. We have, as usual, the integral. Then you divide by minus 1 over 8. And then the limit of integration is from 0 to b. So now plugging in 0 and b, you have this limit as b approaches infinity. If I factor out 1/8, then I plug in b and 0, then I will have exponential to the power of 0 minus exponential to the power of minus 8b. The interchange here is because of the minus sign. If I was to do the you can use without the interchange of them, but remember the minus sign. So this one becomes limit as b approaches 0, 1/8. This is just 1 minus 1 over exponential to the power of 8b. And what we know, as b approaches infinity, exponential grows very fast. So, and that means we're having 1 over a very, very big number. So that becomes a 0, ending up with a number 1/8. So this one converges, and the answer, so this one is convergent, and the answer is 1/8. That's the end of the review for quiz 4.